Hello, this is the Static Tape Lab, Lab 1. In this lab, we're going to be going over the fundamental physics principles, as well as the lab setup, observations, data, and conclusions that we can draw from that, as well as the glow script model. For our fundamental physics principles, we're going to be looking at Coulomb's law and electric force, and we are going to be using that along with Newton's second law to determine the charge on our static tapes, as well as using Newton's third law for the interacting electric charge and gravitational force. For our lab setup, our goal is to use clear tape that has a charge and explore the relationship between the tape and other charged objects to see how they affect one another, as well as use those observations to help calculate the tape's charge and estimate the electron numbers on those tapes. Going into this, we're going to have the assumptions that the charged tapes are going to be point charges. There's not going to be electrons all over it. We are going to pretend that there's just one big mass of electrons. We're also going to assume that the charge is evenly distributed along the entire portion of the tape, and that both tapes A and B have the same charge. When we do this, we are going to have a charged tape B over two neutral charged objects, and we are going to observe how it interacts with another charged tape and record when the distance between the two makes it where the tape B moves from interacting with charged tape A. And using this data, we will be determining the charge and electrons on tape B. So looking at some observations that you can see, when the two charged tapes interact with one another, they are going to repel because they have the same charge. However, when they interact with a negatively charged pin, they are attracted. So what that means is that the tapes are going to have to be positively charged because opposite charges attract. Alright, so when we determine the charge on tape B, we are going to be using Coulomb's law and Newton's second law. We will be taking Coulomb's law and the electric force and setting it equal to our mass and acceleration, which is just going to be our force of gravity on tape B. When you do that, you can take the data collected from our average distances as well as the tape length and tape mass, and when you can take those, and using those values along with the force of gravity, you will isolate the Q in Coulomb's law, which will leave you with a charge tape of 1.1 times e to the negative 8th. From there, we can then determine the electrons on the tape by taking the charged tape and dividing it by the charge of an electron. And we can then determine the number of atoms on a tape by seeing that the length of an atom is 1 times 10 to the negative 10th, and have the length of the tape divided by that number. Doing that, though, we are assuming that we are just looking at the length of the tape itself and not including its width or the height of the tape. And from there, we can go to the conclusions. For the conclusions, if the electrons and protons exchange charges, they go from positive, negative, negative, positive, the observations are not going to change because everything stays the same, and the observations are still like charges attract, or like charges repel, and and opposite charges attract, and there's still going to be opposites and there's still going to be like, so nothing's going to change. And it's important for charged objects to not interact with other objects, because every time they interact with another object, the electrons are going to move, and so eventually the charged object will lose its charge and become neutral. And then Here is the GlowScript model that you can use, and you can see how the two objects are interacting with one another, and the yellow arrow is representing the electric force between the two objects and or tape B and tape A, and the green arrow is representing the gravitational force and how they equal each other. And I hope you have a good day.